So I was basically just going to work through. Can everyone see the GitHub page, by the way? Is it readable?
Yeah, it's working brilliant.
Great. So I was just going to work through this and sort of look at some of the highlights. And the release notes are always pretty dense, so maybe just go into a little more detail. And if people have questions, you should definitely stop me, and I can just answer. I can try and answer questions on all of this stuff. And Chris is online as well, so that's great. So maybe he can talk about the psci stuff, which would be good. So I've been using 091 since we released it, last week or 12 days ago, and just been upgrading all the core Gary did all of the core libraries. I've been working on my contrib libraries and my personal libraries, and all of the tools so far have been working great. Pulp got upgraded. psci has just been working seamlessly for me, and it's been really enjoyable to use the latest release. It seems sort of snappier, and psci is definitely faster. All these nice things, and there's a lot of cool features I think that are in there from a lot of different contributors this time, which is really always great. But yeah, so let's just we can just step through some of these, and if anybody has questions, just stop me and ask questions. So the breaking changes this time, there were quite a lot because in the 08 release cycle, we deprecated a lot of things. The goal with this was to sort of break as many things in the 08 release as we could, rather break as many of the things that we knew we would want to break coming up to 1.0, and then deprecate those in 0.8 and break them in 0.9. So that's what we've done. So probably the biggest one of these is the name resolving. So this changes some relatively minor changes to the way imports work, and this was something that Gary implemented. Texas, I know you were involved in this quite a lot, right? I don't know if you have anything you want to say about it in particular, but
yeah. I mean, the main things are you don't get you're not surprised by imports. That's one. So used to when you did import X, you would get pretty much it would implicitly qualify imports as X. So not only would you get whatever's in X, but you would also get X dot everything. So that no longer happens. And then the other, I think, major change that I recall is that if you fully qualified a module that you had installed, you could get access to it without importing. And that was a concern mainly for the compiler, but also in just reasoning about your code. So that ability was removed as well. And so overall, the imports work in a very consistent, intuitive way.
Yeah. And the other thing I think was that we got rid of qualified. Right? I know now that I've been updating the contrib libraries, I have to get rid of qualified quite a bit. The nice thing about that, though, is that you can just sort all your imports and you don't have the qualifieds getting in the way of sorting it. So that's quite nice. And the other breaking change, like you said, is that we don't have the ability anymore to bring you can't do an implicit import in the middle of a term, like somewhere in the middle of your file. You can't say sort of like debug.trace.trace anymore. You have to explicitly import debug.trace and then use trace. And that's actually, it seems like it's irritating. Like you have to go all the way back up to the top of the file. But actually it's going to hopefully enable us to do things like improve the incremental build times, because we don't have to parse quite as much of the file to figure out the module dependencies. So when we do the initial pass over all the modules, we have to sort of look through each one of them, find out what it imports, topologically sort all the modules by those dependencies, and then we can sort of start working on compiling the modules. Now we only have to parse as far as the last import statements to figure out how to do that topological sort, which means we can do it a lot faster. So that's not actually implemented yet, but this is in preparation for working on that. Okay, so that's imports, unless anybody has any questions on that. I don't have my chat window open, so I just speak up if there's questions, obviously. Okay, so this is quite short, and I think this is worth talking about. This changes to the partial constraints. So this is something again that we broke. We started breaking in 0.8, and now in 0.9 it's become an error instead of a warning. So let's see. I have some experimental stuff here for a demo later, so I need to not use that version of PSCI. I want to use this version. So let's do PSCI, components, just open PSCI session. Does this work? Yes. Okay, good. Okay, I need to check. I have a couple of things. Oh, maybe not. Okay, I'll start a project actually. Then I can demo a bunch of features in there. Okay, so before I start, I'll just show that pulp has been updated. So now if you do pulp init, well, if you do npm install pulp, you'll get the pulp 9, which is compatible with compiler version 0.9, and that will create the default project with all of the libraries that are needed for 0.9. So in particular, if you have a look in bow.json, first of all, you'll see that all of the library dependencies are at 1.0 now. So the 1.0 libraries are for the 0.9 release. Everything else won't work, and the new ones won't work with the old compiler either. So it's important to get that right. And then also we have this new dev dependency now, this PSCI support module. So this is, I'm going to talk about this in a little bit, but this is needed to support the new PSCI. Previously, the code that is now in this library was baked into PSCI. Now it's been split out into its own module. And the benefit of that is that we can now have other libraries like Neon or Preface or all of these alternative preludes that we might want to write depend on PSCI support and actually make their sort of like equivalents of like F, or like it's called task in Preface, and I think it's called task as well in Neon, or that might not be right, but those can actually be evaluable in PSCI, which is really handy. Okay, so I think this has done a barra update, so that's good. I can do a pulse build. Okay, great. So that now works without warning. So anybody who is using 0.8 with the core libraries knows that I would have had about 1,000 warnings at this point, but they've all gone away because all the core libraries have been updated and all the deprecation warnings have been removed. Okay, so I want to open this up in here. Atom's being a bit slow. All right. So I want 0.9 demo. Oops. Okay, cool. So yeah, here's my main module. So I was going to demonstrate the partial changes. So let's create a data type. What do we want? I'll steal Rob's demo from Lambda Jam because I thought that was kind of cool. Rock, paper, scissors is rock, paper, scissors. And let's say we want to define a function beats. I think he called it hand. I don't think I got this quite right. I think he had another type for this. Actually, let's just do that. Okay, so he had another type that was outcome or something, or result. It was player 1 wins, or player 2 wins, or it's a draw. Okay, so we can write this function. Let's say rock, beat, scissors, right? Okay, so in that case, P1 wins. Okay, so let's open up PSCID. If we build, we should get a warning. Look at them. Oh, yeah, not Boolean. That's now an outcome. Sorry, I want to make sure I'm still. Okay, good. Wow, Atom is really slow. Okay, so this is the new error message that you get in this case. So in 0.8, it looked very similar, except that actually, I think the error message was identical, except it was a warning. The difference is in 0.8 we had this this line here. This alternatively, you can add a partial constraint to the type of the enclosing value. This was implemented slightly differently. So in 0.8, the exhaustivity checker would look at the function and statically check if there was a partial constraint on here. So you can make this be quiet by constraining this to say, trust me, compiler, I know what I'm doing. And now, you know, the error goes away, okay? But the problem with this was that, you know, the partial constraint might not have come in into scope from here. It might have, you know, it might not be defined on the function itself. It might be that I'm inside a different function, or I had a partial constraint in scope because I was using the unsafe partial function, or any number of things, right? So now in 0.9, this has actually become, well, we say, you know, the exhaustivity checker elaborates your function so that it's basically going to insert code which requires this dictionary to be here, but you're able to satisfy that dictionary in whatever way you like, right? So, so I can say something like this. Beats equals unsafe partial. I really do enjoy this new import functionality. That's great. And I'll write a function called partial beats. Oh, okay, I need to install this. Okay. Now the compiler should be happy. Oh, okay, what's going on here? Oh, I think I need to put a constraint on there. Talk to the server. That's not good. Okay, so now we can satisfy this partial constraint in any number of ways, right? We can use unsafe partial here and make the error message go away, or we can move this up here and propagate the partiality constraint. But now, you know, if you omit the partiality constraint, because now we're handling propagation of constraints properly, and we were allowed to handle all these different types of partial constraints from different sources, this is no longer a warning now. There's sort of no excuse for not using the partial constraint properly if your function is partial. So what was a warning is now become an error message. So the choice is you either add partial to your function, or you make it non-partial, or you know, if you're using a partial function, you can propagate the partial constraint to the callers of your function. Okay. Does this work? Oh, that's cool. Okay, so yeah, there's no questions on that, then I'll carry on.
Does everyone understand what was going on there? So he doesn't handle all the rock, paper, scissors cases. And so that's called non-exhaustivity. He doesn't exhaust the cases that could be handled. And so he now represents that in the type system with a constraint, almost like a type class called partial, and was showing how it propagates.
Yeah, so another way to think about this is that we have a lot of functions, you know, so in data.array, we have, you know, head, and head takes an array of A to a maybe A. But then in 0.8, we also had a function called head, which was in the array unsafe module, and that had this type, right? So this was an unsafe partial function. And we were sort of, by convention, relying on the fact that, you know, if it comes from a module that's called unsafe, then it's unsafe. And you ought to sort of be thinking about that. But that's exactly the sort of thing that shouldn't be tracked in module name. It should be tracked in the type system, right? So this partial constraint is an effort to move information like that from comments and documentation and module layout into the type system, so it can be tracked statically and you can reason about it in the code.
So what happens to functions like head and prelude?
Right, so in prelude, I think test equals head 1, 2, 3. Oh, I need to add a partial constraint here. Partial. If I import data.array. I don't have this installed, do I? I need to install it. Okay. I want the editor to tell me the type of this thing, but it doesn't seem to want to. Okay.
I think
so one of these modules will provide a partial version, one will provide the non-partial version, or rather, yes, one will provide the version with maybe, and one will provide the partial version with the partial type signature.
Phil, I think Atom still has an instance of psci running for a different project.
Oh, really? Oh, interesting.
Yeah, what you could do is you could start psci with the -p4242 like option, and then it's going to take over that server basically.
Oh, interesting. Should I do that then?
You could. In that case, you should get proper highlights and
oh, okay. Well, let's try that then. 4242. Is that what you said?
Yes. Yes.
Okay. Cool. Awfully slow. There we go. Not sure. Well,
I think it didn't build the. You didn't build the arrays thing yet, so I think that's the problem.
Okay. Let's see. Oh well, it's not essential anyway. Okay, so let's carry on. I'm going to. So these are some relatively minor restrictions. So imports have to occur before everything else, and that was another thing that allows us to do this fast parse at the start of the build. And the source file can only contain one module now. You can't have a file that can contain many modules that you could before. And again, this is just to enable this fast parsing. Foreign function interface changes. So I think this is quite nice. This is a relatively straightforward change, but it's it removes a sort of frustrating convention and actually tidies up the compiler source code quite a lot. So if you look at these modules, these ones haven't been updated, but these module meta comments here that tell the compiler, this is the foreign module for data.array. It goes with this PureScript file. These are actually no longer necessary, and the compiler will sort of infer that this is the correct foreign module by using the file path by replacing the extension with .js from .pers. So you don't need this anymore, but the main benefit of this, I think, is just that it tidies up the compiler source code quite nicely. But also you don't have to remember to type this, so that's nice. Okay, operator aliases. So this is another one of the things which we deprecated in 0.8, and now it's been removed completely. So in 0.8, we started bringing in this idea that you weren't allowed to sort of locally bind operators like this anymore. So you can't define an operator symbol in a let binding, for example, or as an argument to a function, these kinds of things. The reason is, generated code for these symbols is usually quite bad because we can't sort of directly translate this into a JavaScript identifier. So we end up sort of using this scheme where we generate each character would become sort of a mangled version of this name, so it become like something like $hash or something. So instead of this now, what we actually have a restriction in the language where you can't define operators like this. Every operator can only be defined as an alias for a function with an actual name. So if I go back to my code and show that quickly. Okay, so actually maybe we can define an alias for this. So we can say infix for, let's see, beats. And now previously you would have said something like, there'd be an operator here. Now we give the name of the function and we say that it's infix as the operator name that we want to bring in. So I don't know, just come up with an operator arbitrarily. now this builds. And now I can use this. So let's see, test equals rock. Oops, that's an actual operator. Rock beats scissors. Okay. Okay, and now if I look at my output module, I think Atom's having a hard time without all of this stuff open. I'm not 100% sure. Now look at main, then somewhere in here, let's see, test is actually just going to be called, so we don't have any sort of mangled names in here anymore. This is just a direct application of the beats function, because we define the operator to be just a synonym for this function. So this is just a way of tidying up the generated code, especially when you have a lot of operator-heavy code. The generated code could get sort of very difficult to read in some cases. So this actually helps quite a lot. Oh, I should add as well, Gary added support for operator aliases for other types of stuff. So you can now actually define operator aliases for types, rather type constructors, and for data constructors, which is quite nice. So you can say things like data list A equals empty or cons of A and the list A. Then I can say that colon is an infix operator for cons. I always get these the wrong way around. Input array is redundant. Yes, it is. Thank you. PCID. Oh, that's not right.
Yeah, that's not updated.
Oh well. Oh, whatever. That's fine. Okay. So now this data constructor alias here, I can actually use this. I can say test equals 1 colon 2 colon empty, but I could also say I can also use a colon in a binder as well. Int list event. Get this wrong around. That should be infix R maybe. Yeah. Okay. Good. So we can use these data constructor aliases both for construction but also for binding. And I won't demonstrate type constructor aliases, but we have those too now, and those are really handy for certain things. I've been using them for so they're really handy when you have sort of arrow types. I've been using them as I've been updating libraries for things like isomorphisms and equality types and all these types of things. So those are quite handy too. Okay, let's see what else. I won't cover these. Okay, so then there's some enhancements. So I'll just go through these real quick. So programmable type errors. This one was we had a lot of discussion about this and exactly sort of what it should mean. I think we finally sort of came up with a good use case for this. So originally I was trying to sort of come up with a way to give decent error messages when constraints couldn't be satisfied. So one thing that people tend to complain about quite a lot in PureScript as a beginner experience is that you fire up psci for the first time and type in sort of hello plus world or something coming from JavaScript and expect to get hello world, the string. But plus doesn't apply to strings because, and you get a very cryptic error message like string is not semi-ring. Okay, and that means sort of very little to a beginner PureScript user. So we want a way to sort of direct the compiler to say, if you're trying to solve this constraint, there's no way this could ever be instantiable. There's no way to ever make a dictionary for this. So instead of just failing with the arbitrary, the generic message, I'm going to provide you an error message. So we eventually decided that the semi-ring string example was not actually a very compelling one. But there are still some good use cases for this, I think, and one that often comes up when people are trying to derive code for their data types for things like serialization is that the date type is actually not generic. And again, this is a very cryptic error message. Not very helpful. But now we can provide this actually useful error message and explain why date can never be generic. And it's not generic because it's not a sum of products. It's not a sum of primitive things like ints. It's a foreign type that we bring in from JavaScript. So we can give advice here in the error message and say, data is not generic. Consider using int and this function to go back and forth between your serialized type and your working type. So hopefully this is a lot more useful now. And Hardy Jones came up with another example the other day. So there's another class where this is useful. And that is when you're working with things like sort of standard type classes like applicative and monad. There are various types where you might have an applicative, but you don't have a monad, and you can never have a monad. So an example of that is the zip list type. Another example is something like map, where it can be an apply but not an applicative, or validation, where validation is an applicative but not a monad. And it's useful to sort of direct the user and say, this is not if they try to use do notation, for example, actually provide an error message and say, this is not a monad. Here's the reason why it's not a monad, and you might want to use this instead if you want to get do notation. And now instead of getting the generic error message, you'll get this error message now where this string just gets pushed out as an error message. So the way this works in the compiler is that there's a new kind added to the compiler. So this is not a value level string. It has no representation at runtime. It's a type level string. It exists only in the type system. And then there's a new constraint called fail, which is parameterized over a type level string. And you can add this as a subgoal of the constraint that you can never satisfy. And the way the satisfaction, the way the solver works for these for constraints, once the compiler is committed to trying to find this instance, it won't ever backtrack. It will only ever try to satisfy the subgoal. So if it reaches this, it can try to satisfy the subgoal. And there's a little bit of magic in the solver logic that says, if you see a fail constraint, look for a type level literal here and just print out whatever you find. So I think, this is a very simple use of type level strings. There's a lot of work we could do to improve this. We could provide a simple logic for combining strings or pushing types into strings, things like concatenation, or we could, we could have things like singletons, and GHC has something like this, but it has a set of constraints that allow you to sort of reify value level strings as type level strings and reflect them back and all these kinds of nice things. So we could work on those, but for now, this was just a very simple enhancement that sort of solved the problem. It doesn't solve sort of all of these problems. There's as we identified in the issue, there are other sort of related problems that aren't solved by this, but I think it goes a nice way to sort of dealing with a class of error messages that has traditionally been quite poor. So any questions on that?
Yeah, another question, but I just thought of another nice use case for these type level strings, I think, when you showed the generated code for the partial stuff. It would be quite nice if you could have a type level string to insert into the failed pattern match for a partial function. Yeah,
I was thinking about that this morning, actually. So everything there's some connections there, right? And so there's definitely a string that the compiler is generating, and it's a sort of compile time string that is the error message when you fail a pattern match. And now that we're actually doing proper sort of like, there's actually a connection, like an elaboration that happens between the exhaustivity checker and between there and code generation. I think that's a good place to sort of like maybe try and use this sort of approach to generate that. And then maybe we can even get rid of the exception that gets thrown if the exhaustivity checker decides that something actually is exhausted, and skip, if you look at the generated code for pattern match, you always get these error messages, right? If something actually is exhausted, we shouldn't be generating that, but we are right now. And I think there's a lot of there's a little bit of tidying that can happen there, and I think this could be a nice way to structure that. So that would be nice.
I thought, like, for example, if you take the array.head, it would be quite nice if you could say you can't use head on an empty array or something.
Oh, right.
Right.
Let's think.
Like you can encode the invariant. No, you can't encode it, but you can write it out, so it pops up in the error.
The problem though is I don't think there's going to be a way to sort of like do that uniformly. I think this goes back to what Texas was brought up, and I said we had some discussion about this. The problem is this is sort of all sort of constraint level and type level, and there can't be any sort of like value level dependency. So you can't say something like this is the error message if this is an empty value, an empty list, and this is the error message or lack of one if it's non-empty, right? Like we can't have that dependence on the value level. I think it's an interesting problem. I think it might end up having a slightly different solution. What I was talking about was just finding a neater way to push the error message for non-exhaustive functions from the type checker down into the code generator. But I think there's a lot of interesting stuff we can do. Yeah, I think we ought to. We can think quite a lot about this and do some neat things. Okay. If anybody wants like a more detailed demo of any of these, by the way, just let me know. I can do that. Okay. So type toll improvements. So Gary recently added type tolls to the compiler. So let me just give a quick demo of that. PSCI. Okay, so let's import data dot foldable. Say what's the type of fold L, for example, and maybe I want to fold a list. Let's say starting at 0 and my array is 1, 2, 3. I want to fold this using some folding function. But I can't remember, and I always trip up on this, like I can't remember which way around the arguments go here, right? So instead of writing an actual function, I'm just going to put a question mark, which means this is the type toll, and give a name. And then the compiler will say, I picked the worst possible example, sorry. 1, 2, 3, let's say we want to build a string. So we start with an empty string. And the compiler will actually tell you, this is the type of the thing that you want. And then I can say, oh, great, now I can go and fill this in. So I need a string, I need an int. So let's make that this. I need to import the value. So this is really handy when you're doing sort of type-driven development and top-down development. I use it quite a lot in GHC. The improvement that I got added this time is that if you have, let's see, if you have things in scope, then just like GHC, or well, not just like, but we're sort of getting closer to GHC. If you have things in scope, PSCI or the compiler in general will now tell you all the things that were in scope, or I think it's the top 5. So this is really handy when you're doing, like say, type-driven development. I think this is very basic right now. This is sort of an experimental feature, but it's going to get expanded. The reason it's experimental is that we don't actually do any sort of like relevance checking or sorting based on the order in which these declarations came in the source, or whether their types were relevant, or all of these things. I think this could make a really interesting sort of standalone project if anybody's interested in that kind of thing. But it'd be good to sort of, in general, if you have a very large module, you don't have 2 things here, you have potentially hundreds. And it's good to sort of refine these and try and find the things that are the most appropriate. So this is something that will sort of come later, but this is sort of the first step. So for simple functions, it's already quite useful, but there's improvements we can make there. Any questions on that? Otherwise, Chris, do you have anything to say?
I have one question to that. Okay. When I saw how these types work basically for them, how does that work for like rank n types? Does it put the for all in there, or does that get stripped out?
See, sure. I mean, I certainly hope it would either show you a scholarmized type variable, or it would show you ST. Certainly should have ST. Oh, there it is. let's see, if I do run st, that's a terrible example. Okay, so here, so what's happening here is, it's not showing the for all, it's showing this h1, okay? And then down here it will say where h1 is a rigid type variable. And that means that h1 isn't sort of like unconstrained, like these t0, t2, these are unknown types. This is a rigid type variable. So this was created inside of for all, and you're not allowed to try and unify this with other types. You're not allowed to try and make this into some. So h1 is fixed, essentially. Does that make sense? So this is like often overlooked, but this is actually quite handy down here. It tells you what variables are rigid and that kind of stuff. They rank in types.
Thanks, that's good. Great.
Okay, cool. Did you want to talk about the editor support changes, or sorry, I don't.
I could totally show that, or
okay.
I'm not sure. Okay, let's see.
Show it, or can I show it, or how do you want to do it?
Yeah, I'm not sure. Do you have the news? We need to get the PID server working for you at them. David Collins said it would be enough if you just said restart. If you just use like some restart command.
Okay, hold on.
Like with Control-Shift-P and then restart server or something.
In here or somewhere else?
No, just in Atom, inside Atom.
Control-Shift-P. Okay. Control-Shift-P. Nope. Oh, I see. Restart PSCID. Is that the one?
Yeah, I think that's one. That one.
Okay. Cool. Okay. Cool. I haven't used this yet, so.
Yeah. So the idea is if you have non-exported members in that main module,
mm-hmm.
You'd usually not be able to complete it or ask for types with PCID because they wouldn't show up in the extras files. Like they wouldn't show up in the extras files.
So now I should be able to sort of complete this, right? I think I need to update my plugin, but theoretically I should be able to complete sort of this, right? If this were defined here.
Yes, absolutely. But even if like right now you're exporting everything, but even if you've constrained like the module exports for main to just export beats, you'd still be able to update, like test. Sorry, complete test, yes. I think that's quite handy in the, like that might be more handy inside of the UI frameworks where you usually export like these very few members for each component or something.
Yeah, I think I would definitely use that. That sounds really awesome, actually, because I tend to write quite big modules and then sort of like break them down later. Cool. Was there anything else on? I know.
They're not.
Let's see. Oh, right. So Nicholas added some new suggestions, right? So we already saw this one, the missing type declaration. That was when I think like I said, my plugin was slightly out of date, but I think you can do suggestion replacements in PSCID right now. I tried that one. Type wildcard I didn't try yet, but we can try that.
I think you just pushed a new update, so maybe you need that one, like 0.13.4 or something.
Oh, really? Interesting. Okay, so now I should be able to press S, and if this works, then... Oh, okay. Yeah, I think you need a new version of this plugin, so never mind. Cool. But yeah, I've been using PSCID a lot, and and I also was using PureScript suggest lately to tidy up the contrib libraries. That's also pretty great. So that's using, I think that also uses PSCID under the hood, right?
No, it's the other way around. The suggestions you get from PSCID are from PSSuggest.
I see. Cool. But yeah, it's really come a long way really quickly. So I've been using it a lot, and it's really helpful. Okay, so I should just quickly mention this. Sorry, I didn't want to skip over this. So error messages in PSCI and elsewhere now have color. So I'm going to demo PSCI right now anyway, so you'll see it. But this is really handy for sort of, seeing at a glance sort of the structure of the errors. These things, these names are colored in sort of like, dim yellow or whatever the anti-color code is called. But it's really nice for sort of separating these things out as you're sort of scanning over the errors. So I think, Gil, you worked on that, right? Yeah. So, yeah, that was another nice small addition. Okay, so I'm looking forward to showing this one. So, so PSCI, I sort of been giving a few demos lately, and I tried to use PSCI, and it's always been slow. But now that we have a lot of libraries, it's sort of like painfully slow to do pretty much anything in PSCI, or it was in 0.8. But the reason is, PSCI was doing the dumbest thing possible. Every time you typed a command, it would rebuild literally every piece of code in all of your dependencies. And the reason was that, PSCI started as a small experiment and it just never really got fixed. But recently, we've been doing the work with PSCID and try PureScript and all these types of things where we do the incremental approach to rebuilding, where if you're only ever changing a single module, then there's no need to go back and sort of do a full rebuild from the start. We should be able to keep the incremental build products in memory and just do a single rebuild of the latest module against those incremental build products. So that had worked, like I say, really well in other places. So I thought, why not give it a try in PSCI? So PSCI traditionally does not work that way. PSCI, like I say, rebuilds everything, and a result of that is that you could always go into your Bower components directory and just sort of like monkey patch a little piece of JavaScript and then reload in PSCI, and that would be available. With the new approach, that's not possible. So in a way, this change seems a little bit like a regression. There's various things that you can't do. You can't do that on-the-fly modification of dependencies. You can't do reload. You can't bring modules in from the file system after loading PSCI. So maybe we can relax this restriction a little bit later. But for now, this is a new restriction. So in a sense, like PSCI in this release has become less feature-rich. But on the other hand, it's very much faster. And I think it's, it's a lot more enjoyable to use. So let me just give a demonstration. So let's install something that's going to pull in quite a lot of dependencies. So quick check, for example, pulls in a good chunk of core. Okay, so we do less Bower components. Hopefully we have, okay, so there's a good few libraries in here. I've tested this with Halogen as well, which pulls in a lot more still. And it's still very snappy. But if you try PSCI in 0.8 with quick check, then it is like horribly slow. Okay, so the first thing PSCI does when you load it now is actually just compile everything in the dependencies ahead of time. And now, unless you do a reload, you're never going to have to actually recompile these things. And now the evaluation is much faster, and we can do things like quick check in here. So we can say things like test that x plus 1 equals 1 plus x, and we have to import some things. So, test dot quick check import prelude. And you see that it's sort of just instantaneously runs quick check, right? So the reason is that all of the code that I'm typing in here is just being put into a temporary module, and I only need to rebuild that module now. I don't need to rebuild all of the dependencies. So it's as fast as things like PSCID, try PureScript, all these things. Not sort of massive changes on the sort of user-facing side. This also came with sort of like internal changes to the way PSCI is written, and I sort of did a bit of a large refactoring on the internals of PSCI. So the new approach to the building and the new refactoring sort of enables some cool things. So because in particular, so because we're not using, we're not sort of allowing dependencies to arbitrarily change, and once we start PSCI, those dependencies should not change, and we should be able to reuse their build products until the user resets or restarts PSCI, right? So that enables some nice things. Like, it means we should be able to actually run easily in the browser using PSCI. So let's see, I sort of hacked something together this morning, and it's a total hack. But so I let me see if I can just show some code here real quick. Okay, so I modified a couple of files in the compiler. Right? The Cabal file I actually changed to import the WebSockets library, and then in interactive, which is the PSCI internals module, I changed a couple of things. Right, so I added an import for network WebSockets, and I needed a copy file too. And then in here, now my handle command takes a WebSocket connection. Right? And when I handle an expression command, I pass my WebSocket connection down. And then in handle expression, instead of all of the code which previously used node, I just commented this out. Okay. Now instead, I take my PSCI module and I copy it into this temporary directory, which I'm using as my experiment directory. Like I said, this is a very quick hack, right? And I send text data over my WebSocket connection to tell it to reload on the JavaScript side. And then I wait for the JavaScript to send me back the result. And then I print out the result onto the console. Okay. And then alongside that, I have this experimental JavaScript piece of code called PSCI experiment. And that's just this very small index file. And it uses this project called require1k, which is a very small require shim for the browser. So I sort of had to mess around a little bit with the source here because of the way we lay out our files. But I took all of the dependencies that I would build in PSCI and I stuck them in node modules here. And then I just set up this really simple WebSocket loop, right? So when the window loads, I open a WebSocket on this port, which is the one that Haskell is talking on. And once it's open, I say that I've connected, and then I listen for messages. And when the message says that I need to reload, I use require1k, and I just do what PSCI would have sent to Node. And I say require the PSCI module, which just got freshly copied into my Node modules directory, and stick the results on the exports results object. And if that's successful, send the stringified, the JSON, the JSON stringified result back over the WebSocket to the browser. Okay. So now, let me see if I can quit this and start again. Okay. So if I load up PSCI, and I have to use this custom local build of PSCI, and I pass it all my Bower components. So now it will say, instead of sort of presenting a prompt, it will say it's listening on port 9160, and it's waiting for a connection from the browser. Okay. So I started a little Python static web service so that the browser restrictions on security wouldn't hit me, right? So I'm serving on localhost. But now if I go over to my browser over here, I want the console. So if I refresh this, the first thing it does is connect to the WebSocket. Okay, and now it's connected. But now I can say, for example, like print 42. And now require is going and loading all of the information, right? So that took a couple of seconds because it had to go and pull all of the node dependencies over the WebSocket, over HTTP from the Python server that I have running. But if I run it again, it's just instantaneous, right? There's the 42. Hopefully this is readable. Sorry, I'm on quite a big screen today. But if you can't see it, there's a 42 there, believe me, right? So I think this could enable this is a very quick hack, right? It doesn't really work fully, and it involves copying some files around by hand, and I need to script some of that stuff. But I think that can enable some really, like a completely different way of using PSCI, and a sort of different approach to development for PureScript. So we could have, PSCI on one side, and we can have the browser on the other side, and just very quickly do incremental development and see results. And I think where this is going to be really nice, work really well, is where you have libraries like PureScript Canvas and PureScript Drawing or PureScript Web Audio doing these sort of browser-specific things, and I can very quickly get rapid development working and see results immediately in the browser.